This video is going to walk you through on how to do a redox reaction looking at the activity series and reactivity of metals. So to start off, we have a chemical equation where we see that iron 4 is combined with lead 2 nitrate, and we do see a reaction happening. So the first step would be to actually draw out what we see. So we have iron. It tells me down here that we have iron 4, so I know that iron 4 has 4 electrons. And then we have lead, which is called lead 2 nitrate, so I know that it had 2 electrons. And then we also have nitrate, and it looks like we have 2 sets of nitrate. Remember, nitrate is 1 nitrogen with 3 oxygens. And when I look at my polyatomic chart, it tells me it has a -1 charge. That tells me it's going to gain 1 electron, and the reason is that it has 7 and wants to gain 1 electron to make it be 8 valence electrons. So I'm going to place 7 valence electrons around the nitrate, and then show that the lead has given 1 electron to 1 nitrate, has given another electron to the other nitrate. It got rid of its 2 electrons that it wanted to get rid of, and the nitrate has gained those 2 electrons. In terms of the products, for the products, iron is in fact more reactive than lead, and so for that reason, I know that iron was able to knock off the lead, and lead is now on its own. And lead has gained back those 2 electrons that it originally had given to the nitrate and has them back again. Iron, on the other hand, remember, has 4 electrons. It's going to be giving those electrons to the nitrate. Now remember, nitrate can only take on 1 electron because it has 7 valence electrons in its outer area. So if it only can take on 1 electron, how many nitrates do we need? We need to have a total of 4, in other words, 3 more nitrates. So I'm going to draw another 3 nitrates. And I do want to make sure that people are drawing those oxygens with those, because I've been noticing that people will just draw NO without the NO3. The 3 means that you have 3 oxygens. So here I have my 4 nitrates, each with 7 valence electrons, and I'm going to show how those valence electrons are distributed. One goes to, from iron goes to this nitrate, another one of the electrons from iron goes to this nitrate, and lastly the last one goes to this nitrate. So now let's draw or write what that means. So it looks like for our products we have lead, again by itself. It's a solid form, just like solid iron was solid and this was aqueous, and that the iron has now combined with the nitrate, but you notice it's not just 1 nitrate, but 1, 2, 3, 4 nitrates that it's combined with. So we want to show that by putting parentheses with the number 4. So in the written description, we have 1 atom. Oh, now, if you would like, we could actually even balance it. Remember, the amount coming in needs to be the amount coming out. In this case, I have 4 nitrates. I only have 2 nitrates here. I need to have a total of 4, but nitrate can only come in the pack of lead nitrate. So if I add another lead nitrate onto this, so we have now Pb and another set of PbNO32. Remember, lead has 2. It gives 2 electrons, 1 each to the nitrate. That means now I've got 4 nitrates just like I do here. I have 1 iron here, 1 iron on this side, but I don't have 2 leads on this side. So I would actually write again that we have a second lead. So this would be where I balance the equation. And in that case, what I would do is I'd place a 2 in front here, and I'd place a 2 in front here because I have 2 sets of PbNO3 So let's show that in a written description. I have 1 atom of solid iron 4 combines with what looks like 2 ionic compounds of lead 2 nitrate to produce 2 atoms of lead 2 solid and 1 ionic compound of iron 4 nitrate. Okay, so that's the written description. Next, what we want to do is we want to talk about the redox reaction. So for the redox reaction, let's use that picture to help us out. And the picture tells us a lot of things. Remember, the redox reaction is just looking at what the electrons are doing, and particularly focusing on the elements or the cations or anions in which there's electrons being lost or gained. Nitrate, if you take a look up here, nitrate continues to have its 8 electrons. It hasn't lost or gained anything, but iron, on the other hand, let's try this here. Iron, on the other hand, had 4 electrons going in, and then all those electrons were lost to the nitrate. Here, lead had lost its electrons, but now has gained those electrons. And the acronym that we've been using is what we call oil rig. So oil rig is an easy way to remember that when something is losing electrons, it's called, I have to move it up here, oxidation. And when something is gaining electrons, it is called reduction. Okay, so let's start with the redox reaction. Redox reaction, remember, is just looking at which cations are involved in gaining or losing electrons. So we see that iron started off with 4 electrons, so we're going to draw those circles in that equation. And then it combines with lead. Now, lead had lost its 2 electrons, and because it's lost its 2 electrons, it's no more neutral, and it has a +2 charge. Then looking at this picture, it looks like I have, and I should put a 2 here if you want to balance it. It looks like I have 2 leads. That's a +2. Excuse me. This lead now no longer has lost its electrons. It has gained it, so it is back to being a neutral atom. And we show that by drawing those electrons. And iron, on the other hand, has lost all 4 of its electrons, so it has a +4 charge, because remember, electrons have a negative charge. Oxidation, remember, is which of these elements is losing electrons. So this element here had electrons. Now it doesn't have it anymore. They were lost. So we know that iron was involved in the oxidation reaction. So it started off with 4 electrons, and then with this reaction it lost those 4 electrons, and those 4 electrons are now more or less removed from the iron itself. And the way to remember it is always make sure that you have your plus and minuses on the same side of the equation. Reduction is which one is gaining electrons. In this one, lead had lost its electrons originally and now seems to have them. You can see that by those dots. And so we know that lead, we can put the 2 in front of it, started off as having a +2 charge. It gained those 2 electrons, and as a result, we have 2 leads that have 2 electrons. So do you notice how we have the plus and minuses on the same side of the equation? That's going to be key to all of this. So the oxidation reaction is which chemical actually made the iron lose those electrons and give it to them, and it was lead. You see that lead now has gotten those electrons from the iron. So lead is the oxidizing agent, and it's always the opposite of the chemical involved in the oxidation reaction. So since iron is involved in the oxidation reaction, the oxidizing agent is the opposite one, that's lead. And that's the case for the reducing agent. For the reducing agent, we're asking ourselves which one of these elements actually caused the lead to get electrons, and that is the iron.